During World War I, somewhere on the Eastern Front in Europe, an older German artillery lieutenant huddles in his great coat, fighting to stay warm and dry at the bottom of a trench. With numb and trembling fingers, he reviews the latest dispatches from home and finds a particularly bulky delivery. He throws caution to the wind and risks using an electric light to read the long and detailed report. Little does he know that it will prove to be arguably the most important work of creative genius of the 20th century, for it contained the foundation for what we know about black holes, written by a theoretical physicist named Albert Einstein.
The program you are about to hear is fiction, science fiction. We make no guarantees, however, how long it will remain fiction, fiction, fiction.
Supermassive salutations, Cognonauts. It's Monday evening, and I am joined tonight by my two lovely co-hosts, Nick and Mike, and we're going to talk about some black hole stuff. How are you guys doing tonight?
I feel like a molecule in the middle of a black hole being stretched to infinity.
So you're doing pretty well.
Yeah, I'm hanging in there.
I like it. How about you, Mike?
I mean, I'm pretty much in the same black hole, I feel like. We'll see what happens on the other side. It should be fun, though.
Well, that's awesome. I had a little bit of a cringe moment during that cold open. I was talking about this lieutenant huddling in his great coat. That was supposed to be a gray coat, I think. Unless, I don't know. Do either of you know what a great coat would be?
It could have been a great coat. You don't know.
I mean, if you're in a trench.
Yeah, it better be a great coat.
Well, anyway, I thought that it would be a lot of fun to talk about black holes. I know it's a Monday. There's a lot going on nationally and in the world. And so, 2-hour goal as being a nice little form of escapism. I thought we should just focus in on the furthest thing away, the corpses of giant stars. So I'm not going to necessarily explain everything. One, I'm not that smart. And two, there are far better resources out there. But I would like to take a moment to just talk about the history, some strange observations, and just some fun theories that have been recently floated about. And, after all, it was just April of last year that we saw the very first picture of a black hole, which was taken by the Event Horizon Telescope. And that not only confirmed Einstein's original theory, which was all the way in 1915, but it also provided some pretty indisputable proof that these gravitational monsters are in fact real. So I thought that's pretty groovy. And but before we launch into it, Nick and Mike, do you guys recall a time that you took a moment to really appreciate the endless mystery that is space?
Is this a podcast standoff, Nick? You ready to go?
Oh,
first?
yeah. I was waiting for you.
So dramatic.
I know.
Yeah, I mean, I think the first time I learned about them had to be sometime in elementary school, or at least talking about them. I feel like we talked about them in Astro Camp. I was one of those kids that were lucky enough to go to a space camp in like 5th grade.
Nice.
But it's something that I've always been fascinated with, this idea, or just the idea of a black hole.
Yeah, I honestly, I just kind of get lost in the concept of infinity and space quite often. I have to reel myself in most of the times because it just, I don't know. It makes me a little bit depressed, and it makes me a little bit in awe at the same time, if that makes any sense. Just considering the sheer scale of everything is quite humbling. But but it is also a little bit existentially maddening.
I would concur, and I'm glad that you actually said that because I think this talk will have a nice little roundabout at the end based on a more recent theory. Um, and yeah, space. It's interesting that you say it's like awe-inspiring but a little depressing. Um, and thinking about it, like I think my biggest space moment, and I've mentioned this before, was seeing Saturn from a telescope. And you see stars up there. You can see Mars has a little bit of red to it. But when you see a celestial body with like a different shape, I mean, Saturn's very different from any other star, right? Or planet. It's got these rings, and you can actually see them from some telescopes with your eyeball, which I mean, I knew that the scientists weren't lying, but I think when you see something for your own self, wow, that's out there somewhere. And there's certain period of, certain distance between me and this thing, and there's more stuff beyond it. And it's just such a symbol of what we don't know. Um, which, yeah, I guess that could be depressing, but it could also be like it's the final frontier, like Star Trek says.
Yeah, it certainly is.
I think it's just pretty cool to get lost in infinity. Like,
Lost in space. Sorry, I had to.
No, it's fair. It's fair.
Yeah.
It had to happen at least once, right?
Right.
Plus one. Well, and it was funny because like I was thinking about the film Gattaca, and I wanted to watch that. And one of the characters in it, he is obsessed with space because he's this like done with Earth. He's just like I just want to see what's next. So I think I mean wherever you are right now, I think it's just kind of cool to take pause. And so one of the things that I wanted to address was the idea that this theory, or the foundation of black holes and what we know about them, came about almost 100 years ago. And so to think about that, any theory we see today, I mean, 100 years later, if that were to be proven true, it's just pretty amazing, I think.
It's incredibly amazing. And to be honest, it's one of those things that I don't even think normal people such as myself can really grasp how prolific and prophetic that sort of math was.
Right. Well, and when you think about it, it was during a Great War, 1915. You have the flu that came about in 1918. So it's just this really intense time, lots of change, lots going on. And to just round out that opening story, the lieutenant who received a paper from Einstein was named Carl Schwarzschild. Did I butcher that?
Schwarzschild.
Schwarzschild. That sounds much better. So he was the director of the Astrophysical Observatory in Potsdam and an accomplished theorist and mathematician who took time away from his work at age 40 to join the war effort. Now, the document included Einstein's special and general theory of relativity. And of course, this was amid a dreadful war. Schwarzschild wrote back within a matter of days, and remind you, it's like he's in these trenches with this little light, risking his life to read what Einstein wrote. And the work, it's described as the first known solution to Einstein's field questions. Schwarzschild modestly writes, "As you see, the war treated me kindly enough, in spite of the heavy gunfire, to allow me to get away from it all and take this walk in the land of your ideas." To which Einstein responds, "I have read your paper with the utmost interest. I had not expected that one could formulate the exact solution of the problem in such a simple way. I liked very much your mathematical treatment of the subject." So I wanted to just pause there because how wonderful to walk in the land of your ideas. Just a little bit of escapism during difficult times. Just, I don't know. Is it just me?
No, not at all.
It's interesting that it leads to like such great discoveries, right? And then the correspondence between them seems like there's a lot of aesthetic beauty in that math. Like from a language point of view, like a poet's point of view, right? You can look at math
Mhm.
almost like that and the eloquence within it.
Yeah.
So it's strange that it's always times of chaos that ends up bringing us out. Because
Right.
like
Mhm.
even with like Tolkien, right, and the Lord of the
Yeah.
Rings books and all that.
Yeah,
Yeah.
I thought that exactly. And one of the things that's really great about math, and I didn't get very far. I did like AP calculus and then stats to get out of it in college. But one of my roommates was a math major, and I majored in philosophy, and so I was writing essays, and she was doing formulas. By our third year together, she's writing essays about math, and I'm writing these like formulas in logic words. So it looks like math. And it just was really funny to me to see the distillation of ideas into these formulas or logic puzzles. Whereas for her, she was doing math, but you get to a point where you have to sit back for a minute. And what I love about this is that when they're talking about it, a lot of it was what came about was kind of like there's this absence, there's this void here, and it's kind of like explaining the absence of something is kind of what I grasped. That could be wrong, but that's kind of how it felt to me. And then one other thing that came up was the cone about the guy who wanted to write some principles, an individual goal, but kept putting it on hold to help others during hard times. Because again, Schwarzschild already was accomplished, and he was 40 when he went to war. So I thought that should appreciate that too. I mean, would you go to war at 40 when you got all your stuff, your projects in place?
I
No,
mean,
they're a different breed of people.
well, what if you get drafted?
Who won't
40.
get drafted at 40, so I don't have to worry about that.
There's
If I get
usually that
drafted,
draft age.
it depends.
It's
I
like
mean,
18 to 70. We don't care
yeah,
anymore.
yeah, exactly, right.
Well, so what's cool about this story? Well, not that cool because it's so Schwarzschild. He actually about a year later contracts a skin disease while he's on the front line, um, and so he actually joined the millions of World War I fatalities due to just disease, which was influenza, typhoid, trench foot, and trench fever.
Right.
I know it's just terrible stuff going on. But he left behind a solution that completely describes how space time is warped outside a spherical object like a planet or star. And one of the features of this mathematical solution is that for very compact, high density stars, it becomes much harder to escape the gravitational field of the star. Eventually, there comes a point where every particle, even light, becomes gravitationally trapped. This point of no escape is called the event horizon. As one approaches the event horizon, time slows to a complete standstill. Just one more paragraph, and then we can kind of get into some fun stuff. So in 1935, an Indian astrophysicist, Subramanian Chandrasekhar, I think that's how you say it, realized that should a massive star run out of fuel, the sheer gravitational pressure of that mass would be concentrated to a point causing space-time to collapse in on of itself. And he bridged the gap between mathematical curiosity and a scientific possibility, thus seeding the theory behind the formation of a real singularity with extreme consequences for the fabric of space-time. Um, so that's pretty cool. I mean, like, first of all, when you hear space time, does any image come to mind, or is there
Yes.
a way that you kind of conceive of that?
Remember when Homer became 3D
Yes.
and he was in that space-time grid, and
Mm-hmm.
basically you can see like I guess I don't know what happened, but something pulled the fabric all the way down into kind of like a black hole sort of shape.
Mm-hmm.
That's every time I think of space-time, I always think of that image.
Yeah, no, it's true. So we're gonna get into spaghettification. I don't know if I'm saying that right, but that's kind of the same thing. But Mike,
Mm.
how about you? Any visuals kind of anchor your understanding of black holes?
Um, I guess just the dots and lines, like is it called a wave graph? I forgot what it's called, but there's some representation of it for me. But since I have a experience in like I guess modeling or thinking of spaces in visual ways, it all kind of is the same thing, even with black holes being in there.
Mm-hmm.
I don't know if
No,
that
that's
sounds pretentious or
No, that's good because like I said, I was a little scared to get into this topic because I mean, I don't know all the math behind it. It's very complex stuff. But I do think that there's still a level where the layperson can have fun with it. And maybe I can pick your brain a little bit too along the way. Um,
Oh,
yes,
sorry. May I ask one question before
yes.
we proceed? And I don't know if you have this in your notes. I'm trying to look to see if it's in there so I don't spoil it. But maybe Mike can speculate on this
Oh
one.
no. Oh no.
I'm going to put you to the test.
Yeah, look at
All
that.
right.
I'm on the spot.
Right. So when I was reading up a little bit about black holes, they said something interesting about the event horizon. And when you're looking at it, is that you can see the you can see behind the black hole while you're looking straight at it. And it's because time and basically reality is bending so that you can actually see what's behind the black hole as if it were above it or on the side of it or in front of it.
Oh, yes.
Hmm.
We'll get a little into that.
Okay.
I mean, we're
There's
about to get into the event horizon section. So yeah, go ahead, Mike, if you have something to
no,
start
no, no. Hop into it. I don't want to lead people down the wrong road before we get to the research, and then I just always look like the idiot, which I don't mind, but
with.
I'm actually really curious because
Yeah.
if I can't, if you're done and I can still pull the same analogy or the same image or the
Mhm.
same comparison, I'll be happy.
Mhm. Oh, good.
So go.
Okay. And I only have 4 bullets. Like I tried to kind of keep it sort of neat and tidy because you could geek out really hard on like a very small thing, but I'm like if you're cooking and listening to us right now, I want to keep it kind of fun. So, about event horizons, I just have 4 little nuggets that I thought was cool. One, once a particle crosses the event horizon, it cannot leave. It can't. It's there. Gravity is constant across the event horizon. And the event horizon is the threshold around the black hole where the escape velocity surpasses the speed of light. Um, and then let's see here about that photo. I don't know what photo I'm talking about in my notes, but I talk about these black holes are dark most of the time, but when their gravity pulls in nearby stars and gas, they do flare up into intense activity and pump out a huge amount of radiation. So when you see an image with that like that little red glow around it, it's because it just ate something. So those are kind of like the few facts that I have, which probably leads right
Wow.
into what you were about to say, Mike.
Nom nom nom.
Yeah.
So if you think about light traveling towards a black hole, it's going to be doing its thing, right? And then it gets caught by the event horizon. But it may not be going straight into the black hole. It may be caught in like a slingshot type way, where it gets pulled and it spirals into the black hole.
Mm-hmm.
But there may be. This is where I don't know. This is where I'm just sort of imagining now. Or probably was imagining before, but whatever. Uh, as it goes around, it might be slow enough maybe for you to see, or that's why you see like the behind part. That's where I wouldn't know like how fast light can travel for you to see it versus not see it.
Mm.
I
Mm-hmm.
don't know if that's the question I'm trying to form, but the analogy I was going to make was like 10, maybe 2010, 2012, that period. The military was working on a suit for invisibility. And the
Mm.
basic premise was that they were going to have a bunch of cameras on your back, on your front, all around you, and a bunch of little tiny screens as well. And whatever was shot from the back would be projected on the front. And this is
Mhm.
basically the same premise in a way, right? Like
Yeah.
you're looking
Totally.
behind the black hole because those particles of light or whatever it's being thrown around or being sucked into this black hole so that you can see so that you see the front, the back becomes the front.
Yeah. Well, yeah, it's like obfuscating your visual pathways and the way that the light is bouncing all that information onto your eyes, which is crazy.
Yeah, like yeah, I mean because the light has to hit your eye for you to see the back of the black hole, right? Like it
Mhm.
has to escape somehow. So there might be things on the edge of the event horizon that gets thrown out as it's being sucked in, because everything kind of works on spherical patterns. I would assume, like
Mhm.
orbits and all of that, right? So
Mhm.
it's just going to get sucked in like a water going down the drain.
So that's really interesting because me being a layperson, I've always kind of thought of black holes as two-dimensional. And I know that that's like not reasonable, but I would think them as some sort of toroid, right? It's not like it's not a flat disk, it's not a sphere, but it's like a toroidal sphere almost. Well, we don't know what the back end looks like, but maybe the top end of a toroid.
Definition of toroid for 300, please.
Toroids are like what you see when so you think like a graph, like a sphere, but then like you can see the inside, and the inside goes up over the top of the sphere and then down, and then from underneath it goes back up. So it's like that energetic, like sort of feedback loop. No. Well, think of like a top.
Are you saying like it's like? Oh yeah,
Huh?
like Inception, the little spinny top from Inception.
Well, yeah, you can think of it like that. If you take a top and then like take the little edge that it spins on and then just cut it flat, and then you have the little,
Oh,
spinning part and the round disc. That's
I
kind of what I'm talking about, where it's like, the piece of matter that is so dense has pulled it into this cone shape almost.
Yeah, I think that's kind of what comes to mind too. Is just like this little swooping in, or like Mike said, a drain. Yeah, I mean, those are all kind of in that same realm. Now, when you think about black holes, do you think often about spaghettification? Because this is like the coolest thing, and I had to just like talk about this for a minute.
Is that when it basically makes molecules, long molecules?
Yes. Yeah, it's pretty terrifying. So, like, apparently, if you venture too close and then you cross over the so-called event horizon, you'll never escape. Now, there's debate if you can even get to the event horizon, because apparently you'll just be crushed by all the matter and stuff.
Yeah.
But
a human can certainly.
But they said for like small black holes, you'd never survive the approach. The tidal forces close to the event horizon are enough to spaghettify anything, which is to stretch until it is a string of atoms. Okay, so that's really crazy. Just hold that information there, because we're going to get into tidal forces. So tidal forces are named that because they're similar to the way that the moon and the earth work to affect our ocean tides. And these tidal forces increase dramatically as the distance between you and the black hole shrinks. So there's just tidal forces all over the place. I'm a little fuzzy on that, but what that means is that the gravity is acting on your feet much stronger than the gravity that's acting on your head as you launch into this black hole. As a result, your feet are going to begin to accelerate much faster than your head. Your body will start to stretch out, not uncomfortably at first, they note, but over time, the stretching will become more severe. And astronomers call this spaghettification because the intense gravitational field pulls you into a long, thin piece of spaghetti. It's a painful conclusion. And when the tidal forces exceed the elastic limit of your body, you will snap apart at the weakest point. Scientists imagine that to be your hips would separate. And then according to Stephen Hawking, apparently the hip's like the weakest point. Yeah.
Never mind, continue. Sorry.
I know, I'm thinking of like drawing and quartering back in the days. But yeah, and then like Stephen Hawking, he said that once your hips separate, it's going to come down to your bones, your muscles, your sinews, and then even your molecules will begin to separate. And you might even see your lower half floating next to you, and you'll see it begin to stretch anew as tidal forces latch onto it. So you'll separate, and then you'll watch yourself as you separate again and again.
It's pretty awesome.
Yeah. Each half is going to snap a second time, and in a matter of seconds, you're a goner, reduced to a string of disconnected atoms that march into the black hole's singularity like ants disappearing into a colony.
It's very descriptive.
They've thought about this.
Yeah.
Well, I mean, have they ever done it though? No.
Right.
Well, in 100 years from now, we'll have some schleb, volunteer to do it.
Can we just send like a GoPro through the black hole?
This is the shape that I was talking about just before we move on.
Oh,
That's a
cool.
toroid sphere.
For those of you listening, if you were to take a slinky
That's
and
Homer's
lay it on
donut.
its side and connect it, that's kind of what it looks like. Or a donut. Yeah,
Yeah, a donut. Yeah,
totally. Yeah, Nick, you should just said a donut. Everybody
I'm
knows what that
sorry.
is.
Donut.
Yes, exactly.
Yeah, lots of Simpsons references.
Right.
References. Well, I was just going to say one thing too. Scientists have observed black holes ripping stars apart, which is a process that releases a tremendous amount of energy, creating those big flares. Um, and some scientists talk about the poet Dante and the words over the gates of hell, which says, "Abandon hope, all who enter here."
Mm.
So I think that's just kind of a fun point to pause. You know, based on everything we know, a black hole is descent into death and darkness, nothingness, the fabrics of everything we know, every physics law that we have can't really predict what would happen after that point. And like, just like to fathom that.
If
How
you
do you
could keep, sorry, go ahead, Mike.
go for it, Nick?
Oh no, I was just gonna say if you could keep your consciousness while you're going through a black hole, would you?
Shit,
Oh,
shit,
yeah.
shit, 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 shit.
Oh, of course.
That's just all I would be saying.
I'll be trying to do like the Matthew McConaughey Interstellar type
Yeah,
things.
right. Talking to your future daughter through a bookcase. Yeah.
Oh man.
Be amazing.
Right.
All those little weird events that happen in your kids' lives that they can't explain was really you just disintegrating.
Yeah, slowly.
Seriously. Well, and then here's a question because I didn't get any frame of reference for the duration of time that the spaghettification would occur. I'm sure it depends on the size of the black hole and your proximity to different locations of it. But if you did maintain your consciousness, at what point do you think you would lose consciousness? Like, would you be conscious when your torso snaps in half? But what about like your neck? And like,
Well, I mean, if you were able to survive these things, I think that's even more interesting, right? Because past the event horizon, time stands still. So, how long does it take?
Dude, right. These ants, your molecule ant body is marching through it. Now, but it says time stands still but that's like the time that we know. If you're inside of the black hole, things might be totally different. I don't know. Mike?
Yeah.
You're still a vector, right? Like you're still being pulled through something. You still have you're still moving in a direction. I was gonna take like a Turing point of view on this of like once your molecules all break up, if we can reconstitute them on the other side by taking in like the string of all molecules coming out of the black hole, if we ever get to the other side, the whole string of molecules coming out of the black hole and read them through some sort of machine that can reconstitute a consciousness or a body. I think that'd be pretty cool. But I was trying to think of it
teleportation.
Like that.
Yeah.
Wait, say that again?
I was saying it's teleportation.
No, basically, right?
Atomize yourself and then reconstitute. Yeah.
The My TV thing.
Yeah, yeah. My TV. Yeah.
Yeah, I mean, I think it's but one thing that's interesting to me is that it's easy for my mind to get around breaking everything down. Like destruction that's like, oh yeah, that's super easy. But the idea of being reconstituted on the other end, that's a harder sell. I would love it to be true. I'd love it to be like a time portal thing. But I mean,
what if humans are just like really complicated IKEA furniture?
I hope
yeah,
there's
some
really
alien on the other side's like, oh man, they didn't give me the hex nut.
Yeah. Well, you
always missing one of those.
Yeah. And then someone else comes to the black hole. It's like, ooh, hex nut.
Yeah, I'll just take one of them from them. Yeah.
Yeah. Give me 5 off though.
Well, and I think it's really interesting to talk about the other side of a black hole, right? Like, so maybe perhaps we don't know what the other side of a black hole is because our side of this side of our galaxy actually doesn't have the other side of black holes. Perhaps we're only seeing one side and the other sides are across the galaxy or the universe.
Well, and here's another thing to really bake your noodle. Do you think that we are living inside of a black hole right now?
Dun dun dun.
Da-da-da-da-da-da-da.
I mean, it would. I don't know. That seems like. How do we get there? How do we get there?
Well, there's a National Geographic article about this, and it says that our universe may reside within a very, very vast black hole. Now,
Oh,
they ask you
jeez.
to, yeah, we got 1, 2, 3, 4, 6 bullet points, and then we can chat about this. So you're going to hold in mind that humans existed. Wait, before humans existed, before Earth had formed, before the sun ignited, and before galaxies arose, before light could even shine, there was the Big Bang. Big Bang. This happened 13.8 billion years ago. But what about before that? Many physicists say that there is no before that. Time began ticking, they insist, at the instant of the Big Bang, and pondering anything earlier isn't in the realm of science. That we'll never understand what pre-Big Bang reality was like, and that such notions are just beyond human understanding. But there are a few unconventional scientists that disagree. These physicists, it's a hard word, these physicists theorize that a moment before the Big Bang, all the mass and energy of the nascent universe was compacted into an incredibly dense yet finite speck. Let's call it the seed of a new universe. This seed is thought to have been almost unimaginably tiny, possibly trillions of times tinier than any particle humans have even been able to observe. And yet, it's a particle that can spark the production of every other particle, not to mention every galaxy, every solar system, planet, and person. So, if you wanted to call something the God particle, this seed seems to be an ideal fit. So just want to stop there for a second. Any
Yes,
questions? Any
please.
ideas?
Yes. Because this is all so silly because it's like I love how and to any of my atheist friends, please don't be offended. I'm just going to take a slight critique here because I think it's hilarious where it's like scientists are so desperate to not say God that they're like, no, 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 no. See, what happened was there's this tiny thing that was billions of times smaller than anything we've ever recorded before. And that's what created the Big Bang. Not that it just came out of nowhere. No, no, no. It was a very, 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 very small semi quantum particle that created everything. Oh, okay, okay. Like
like
Well, no, it's
you
actually
might
a
as
little bit
well be
different.
saying God by this point.
Well, that's the theorists. Like the scientists are saying there wasn't a seed. They're just saying Big Bang, bada boom, and that's when things start.
Well,
But that does
that's
seem
even
a
more
little
silly.
weird, right? Yeah,
Yeah.
like how can you have time that starts
Just starts.
that just starts,
Yeah.
right? Is that just
Yeah.
me?
No, it's not just you.
It's
It's
not you.
ridiculous. This is why I am filled with existential dread every time I think about space. Because it literally makes no sense and it makes me want to die.
Seems so
Shit.
peaceful up there, though.
Yeah, it's just things floating around.
Not making sense. Yes.
Some of the best parts of life is when things don't make sense.
Sure,
It's
sure.
true. Just
Sure.
fly right into the black hole. Spaghettify.
Spaghettify,
It's a
and
hard word.
reconstitute.
Yeah,
You'll be
yeah,
fine.
totally. Just trust the process.
So you guys say.
Have
So you
faith.
guys say.
One must
Have
have faith.
Well, should I continue? Did you want
Yeah.
to say anything, Mike, about any of that?
No, keep going.
Okay. So how could such a seed be created, one might ask? One idea from Nikodem Poplawski of the University of New Haven is that the seed of our universe was forged in the ultimate kiln, such as inside of a black hole. Now, it's important to know that over the last couple of decades, many theoretical physicists have come to believe that our universe is not the only one. Instead, we may be part of a multiverse, an immense array of separate universes, each its own shining orb in the true night sky. How and if one universe is linked to another is a really big source of debate and completely unprovable for the moment. But one compelling idea is that the seed of a universe is similar to the seed of a planet. It's a chunk of essential material, tightly compressed, hidden inside of a protective shell, like a seed. This precisely describes what is created inside of a black hole. Black holes are the corpses of giant stars, and when such a star runs out of fuel, its core collapses inward. Gravity pulls everything into an increasingly fierce grip. Temperatures reach 100 billion degrees. Atoms are smashed. Electrons are shredded, and those pieces are further crumpled. So the star by this point has turned into a black hole. And enormous black holes, some of them millions of times more massive than the sun, have been discovered at the center of nearly every galaxy, including our Milky Way. So I know it's a lot of information to hold, but you
So
guys
the
still
universe is just a pack of birthday hats.
kind of. Kind of. I
It
think you're
is.
kind of knowing where this is headed. So just a little more. I've got a couple more bullets and we can get into it. So if you use Einstein's theories to determine what occurs at the bottom of a black hole, you'll calculate a spot that is infinitely dense and infinitely small, a hypothetical concept called a singularity. But infinities aren't typically found in nature. The disconnect lies with Einstein's theories, which provide wonderful calculations for most of the cosmos, but tends to break down in the face of enormous forces, such as those inside of a black hole or present at the birth of the universe, a universe, or our universe. So the physicists like Dr. Poplawski say that the matter inside of a black hole does reach a point where it can be crushed no further. And this incredibly dense seed might be incredibly tiny with the weight of a billion suns. But unlike a singularity, it is real. And the compacting process halts because black holes spin. They spin extremely rapidly, possibly close to the speed of light. And this spin endows the compacted seed with a huge amount of torsion. And it's not just small and heavy, it's also twisted and compressed like one of those spring loaded snakes in a can. So it can suddenly unspring with a bang. Make that a big bang, or what Dr. Poplawski refers to as the big bounce.
Mm.
So I'm just going to pause there because I know that was kind of a lot and I can go back.
That
But
makes sense.
yeah, I mean, like that really resonates with me. That kind of feels like it makes sense because I don't buy this there was nothing before the Big Bang nonsense. And if we have all these universes and all these black holes, it would make sense that there's sort of this like eternal fractalization of a star dying and its death giving birth to like a whole bunch of new shit.
Big bada boom.
Yeah.
Big bada boom. Yeah, no. I mean that makes sense, right? Like the even just the cyclical nature of life and death. Right? Like you have that long life of a star, it dies, turns into a black hole, explodes, and then gives birth again.
Mm-hmm.
And then true, like what was before the, I find it a little silly that people are like, let's just not even ask the question what was before the Big Bang. I think
Yeah.
also building on Nick's idea of like this weird beating around the bush of God from scientists, but scientists haven't figured out their artist yet. So how would they even know about? Anyways,
Ooh.
yeah, just get real fiery with it. No, it makes sense though, right? That this explosion can give birth to whole new universes.
Yeah.
Mhm.
Definitely. It's like two party hats, like tip to tip. You know what I mean? So it's like
Where
with
one
the
ends.
yeah,
There begins.
the other begins.
Can I ask a multiverse question?
Mm-hmm.
Sure.
Do you think every time we have a near-death experience, the other version of us dies?
It's like Jet Li's the one.
I was just thinking about Jet Li's the one.
I think it's definitely possible. I definitely have had moments where I'm like, damn, even when they weren't like near death, like, damn, if I had stepped off that curb a little bit too soon, that car would have hit me, you know? Like, Yeah, so I definitely think about that often. I'm like, oh man, did one of
Now
me
there's this
just
whole
die?
yeah,
Like,
this whole subset of realities just got made
yeah,
and ended real
exactly.
fast.
This is what drives me insane, man.
Well, and then it starts getting even crazier because you think about your soul, right? Like I just think I'm me and I have my one soul. But if there's a whole bunch of different, and see, I get a little tripped up because with the multiverse, we tend to think it's replicas of our universe, but that might not be the case. It could just be a whole bunch of multiverses,
It's just an infinite possibility of
infinite possibility.
I
Yeah.
would
So
hope
then
though
you could
that
assume there would be duplicates.
yes.
yeah,
Mm.
I would hope though that it's like a gradient, like looking at like a color wheel of universes or something. Like I hope that there's enough in between where it's not like a sparse distribution of universes. It's like a nice uniform distribution.
Yeah, but then like how many universes are there where like you have a mole somewhere different on your body? You know what I
Yeah.
mean? Like
Yeah.
everything exactly the same
Those are the
except
ones you got to get rid of in the
yeah,
near
right.
death experiences. Those are the
Right.
universes you have to target.
But then again, like if that's the case, like are those all different souls? Or does that replace the concept of a soul? Because if I die in this reality, I'm alive somewhere else and I will
What
continue to be alive
what
for
if this
eternity.
Sorry, I don't mean to interrupt. I got excited.
Okay. It's exciting stuff. I'm glad.
No, no. What if the soul's like a collective thing, like spread out a bunch of Aylas, and every time you have a weird dream, you're actually seeing another Ayla's experience in a parallel
Yeah.
universe.
I thought about that too.
The rest
There's
of the Knicks that are alive, they're really boring then.
You're trying to stay
My
alive.
dreams are so boring.
It's like there's this one Nick. We have
Yeah.
to-
oh my gosh.
It's always something mundane like talking to an ex-coworker or I'm at a family gathering or like
Which is crazy because I'm having dreams about like pterodactyls and giant wolf dogs. I had a Langolier dream. So yeah, I mean, like if that's a basis of evidence, there's some frightening universes out there. It's just crazy.
And some pretty cool ones too.
I'm in
That's
the boring quadrant. Sorry.
Got to build a better ship, man.
Yeah.
Need a better ship.
Right.
Yeah, exactly.
Well, this Dr. Poplowski, he's pretty cool. So he's got another fun nugget. This one's shorter. He said it is possible, in other words, that a black hole is a conduit or a one-way door between two universes. This means that if you tumble into the black hole at the center of the Milky Way, it's conceivable that you, or at least the shredded particles that were once you, will end up in another universe. This other universe isn't inside ours, adds Dr. Poplowski. The whole is merely the link, like a shared route that connects two aspen trees.
You just
Which
get
is,
like mist. You just get like a particulate mist on the other side.
yeah, which is kind of weird because, like, when you think about the nature of a seed, right? So, like, there's a flower and it pollinates, and that flower dies, but its seed went somewhere, and then that gets planted and it makes another flower, and then it seeds. So it's like when you think about the theory of or like evolution, is it the same from the universe perspective in the sense that like what were the universes billions and billions of years before our current one looking like? What particulate creatures came to be us?
Well, I don't know. I mean, it's a mystery, right?
Yes.
I think also too. It's like why do we assume that gravity works the same way at the end of a black hole? Because I mean, like if we're thinking about the Big Bang, it just creates another Big Bang. Well, there's been said before, and I think I've said it here on the show, is that if everything spread out in a symmetrical manner, no matter would have been created. The only reason that matter was created in the first place is because it was able to spread out asymmetrically so that some could start to congeal together. I just don't know. I don't know why we would expect that gravity would work the same way.
It
Well,
makes publishing papers a hell of a lot easier, let me tell you.
Yeah, that's true. Okay.
seriously. Well, and I think that's where like you get this Einstein and his colleague dynamic because you can have an observation based on your experience and your studies, and there's this gap, or that all of your theories are based upon the assumption of a unilateral spread or distribution. And you got some crazy guy like Mike, and he's all about, three-dimensional models. And you're like, yo, I just thought about this. Can you pop this into your model and see what pops out, And so it's like this melding of minds or walking through the field of one's ideas to see what like idea can be fitted in the DNA chain strand that's building us towards a better understanding of everything, which is so cool.
Well, and it's really weird too because like we're really talking about the golden age of physics. This is when
Oh,
Einstein was
just wait.
knocking around Niels Bohr. Like, it's weird to me that we haven't made, and I know that we have made certain discoveries of things that were postulated in the past, but it's interesting that like very few. I mean, I'm thinking maybe like a couple people that I know, but it's interesting, I guess, that there's no rock star status to that anymore.
Mm. Well, we're going to actually go into some folks that won the Nobel Peace Prize over the past couple of years.
Mm.
So to just round out this last thought, Poplawski talks about all of us here in our own universe. And just to use the words from this article, he suggests that we might be the product of another older universe. He calls it maybe our mother universe. That the seed this mother universe forged inside of a black hole may have had its big bounce 13.8 billion years ago. And even though our universe has been rapidly expanding ever since, we could still be hidden behind a black hole's event horizon, which is pretty crazy.
But yeah, it's crazy. But I'm just wondering. Okay, so then why do we have time and like measurability? It doesn't. I mean, like, okay, I'm obviously an idiot. So like
No, no,
these
you're
things
not.
need.
I
No,
think
no.
time is something
I'm
we
I'm
created to make sense and measure things,
Yeah,
personally.
I'm not a physicist, so I don't know the answer to these things. So I'm just asking, random questions. But it just seems very strange that if our universe is still behind inside the parameters of an event horizon, how are we able to measure it at all?
I mean, if we're inside an event horizon, we're moving towards a black hole. Gravity moves at a constant rate with inside of the event horizon. If you take if you measure the particle or the thing moving from one place to another, you can start to build a metric system, right? And
Mm.
humans love patterns. Humans
Mhm.
need to measure and be able to do things. So it makes sense that we would build up a concept of time, whether or not it exists or not, even if you
Mm.
want to get real, like heretical, I guess. But um, I I think there are things that humans make up in order, maybe out of sake of convenience or the sake of not going insane when trying to think
Mm.
about these things. And I definitely like see time being one of them. Um,
Yeah. Well, I think I would agree. Wait, did you have more to say?
I did, but I lost
Okay,
it in
go
the
ahead.
black hole. Oh no, I was going to say um, about the mother universe thing. Imagine if there was life in that mother universe that learned how to travel through black holes.
Mhm.
Because I think that's the thing we're going to have to do eventually as a species, right? We're going to have to escape this universe before it implodes if we think that it's going to implode. That's like the human end game thousands and thousands of millions of years from now, right?
Yeah, and imagine thinking 13 billion years ahead into time. Like
Y'all cute. Y'all think that we're gonna be around that long?
Hey, man, we can live that fantasy, all right?
Okay.
No, but it's true
Worst
though.
case
I mean, like,
scenario is that there would be an Elon Musk on Mars who tripped up on this exofathom and was like, "Ah, shit, I got to get out of here."
Yeah.
did not take that into account. Shit. But it is kind of crazy though that like in theory, what if there was a Nick in this mother universe and it took all of 13.8 billion years for you to finally reassemble?
Mm. I like that idea. I mean, like it does really make sense because, if you think about everything just basically being carbon or hydrogen that's been, allowed to sit for 14 billion years, then yeah, it makes a lot of sense. It's a very cool idea. I have an issue with the parameters of it being within an event horizon, but
Yeah.
that doesn't mean it's incorrect. I mean, I know that Eric Weinstein has the universal field theory where he's talking about something kind of similar. He talks about the active universe being like a football stadium where, the everything that's going on is basically what's on the field, but then you have the bleachers and the thing that surrounds the field. So, I mean, it would be kind of interesting if that's where he was going with that. But it definitely seems to have a sort of like consensus, at least with him, that there's something encasing this universe.
Yeah, and I think that when dealing with the limits of what humans can truly know, this is where placeholders become handy. So, for instance, this concept of time, it does break down inside of the black hole. That's kind of where the limits of a lot of this stuff happens. And so the fact that there is a contradiction out there somewhere already proves to us that like it's flawed, because if you expand scope you might know more. But the thing is I think that we have to build our knowledge based on what's observed and what's been proven. And so when you have these variables, you kind of say, okay, well, this is my closest approximation to the truth. It's about 95% true because it works on Earth, it works in the nearby solar system. So I'm just going to keep building on that.
Mm-hmm.
But should I one day find out that's not true? Well, that's okay because I can go back and say, look at this variable. Let me reinsert this new information and see if all of the answers come out closer to a new truth. And so yeah, it is kind of interesting to think about atheism and religion and scientists. And because I do think that a lot of scientists who are in the pursuit of truth, they know themselves that they're just kind of holding space for a truth for a capital T. They're
Mm-hmm.
waiting for that. And
Yeah.
so that's where, like you said, we really haven't had a lot of accelerating information until recently because some of our new tech is letting us observe things that we couldn't observe previously. We have telescopes now that are closer, like they're further out. And we also have the ability to bounce information on against like other satellites, and we can get these really cool pictures. So that comes into the Event Horizon Telescope, which is what captured the very first picture of a real black hole. And one of the craziest things that they witnessed like in the past year, is that it wobbles. That the black hole isn't just there sucking in and just like doing its thing. All of the Event Horizon pictures are wobbling and it's moving. It's very fluid, which is kind of weird, and they don't know exactly why, but they've been observing it. And let's see here. I thought this was a cool quote to your time question. John Wheeler says, space time tells matter how to move, matter tells space time how to curve. And that is to
Mm-hmm.
say that matter and space time are inextricably linked, with gravity mediating their interaction. So, this
Mm-hmm.
concept of gravity is also an interesting one. And let's see, I'm not going to get into these bits, but this is something cool. So just September of this year, like 2 months ago, we did actually learn a new fact. It was about ripples from past black holes, because apparently more than 7 billion years ago, two very immense black holes circled each other until they collided and merged. And a cataclysm so intense occurred that it sent ripples soaring through the fabric of space-time. And in the early morning hours of May 21st, 2019, Earth trembled from the vibrations set off by this distant carnage, cluing in astronomers to the biggest cosmic bang they'd ever detected, and one that defies theoretical expectation. The signal picked up by two observatories, LIGO in the United States and Virgo in Italy, came in the form of gravitational waves or disruptions in space-time that massive cosmic events can set into motion. Ain't that some shit?
It's amazing.
That
It's
wrinkled my brain.
amazing. It's like when I learned about
Nick's
carbon.
over there just like writhing in existential
I hate
pain. I'm like,
it.
this is so awesome. I could get ripped in half twice.
So, and two black holes collided 7 billion years ago, and we just felt it 6 months ago.
Yep. May 2019.
Oh,
So
19. Sorry,
little
over a
over
year ago.
The Earth actually trembled from these vibrations. Now, what's cool about that? I mentioned carbon dating, so just to, if you're out there listening to this, just to kind of play with it, carbon dating is really cool because you can tell how old something is based on the amount of carbon in it. Is that what it is? Is the amount of carbon? Like
The age of the carbon.
yeah, it's like a tool that gives us, again, with this time thing, but again, like if time's made up, how is it that we can use like tree ring dating, carbon dating to accurately give us this linear presentation of events and times? So again, 95% our time thing is working with us. And so then another way that they're measuring time is in this gravitational vibratory, what is it? It's gravitational waves, which I don't have a lot of knowledge about, but I did think that was pretty crazy.
You can
And
see
this is at this
gravitational
time.
waves in the picture on the screen, where the little planet is on the left-hand side.
Oh,
no,
yeah,
little
see.
planet.
that little planet. That's really
You're
cute.
about to be swallowed up.
Yeah, it
Oh.
doesn't look good for that planet.
Well, and so it's crazy because this happened again in August 14, 2019. We learned that 800 million light years away, a black hole devoured an unidentified object, and the resulting cosmic merger released enough energy to wrinkle the fabric of space-time. And that's what a gravitational wave is. It's a little wrinkle that travels through the universe and eventually washed over Earth on August 14th last year.
How? Sway? How?
Well, this is a new
Honestly.
technology. It just became available in 2015, and it earned the Nobel Peace Prize, or the Nobel Prize in Physics. You can learn more about it. It's the LIGO Virgo collab for gravitational wave events at ligo.org. And they really need, like, to zhuzh up their website, but it's pretty cool. Like, just they even have some study that's developing because they can't publish anything until they've debated and researched and done the math and stuff. So I predict that we're going to hear a lot more coming out of them for sure.
There's the most. Sorry to sidetrack. You might be able to find some stuff on Wikipedia. There's a point in my academic adventures where we couldn't use the books because they weren't published yet. So the professor would dump everything on Wikipedia. And of course, you learn early on, like, not to use Wikipedia as any of your sources. But there's like a small little rebel group that uses it for publishing material. So I think maybe if you follow some authors, there might be something that's not published yet, but like a soft publish.
That's cool. Yeah. I mean, yeah, because like I wonder too, like on some of these sites, they can show you like recent images, or they could be like, hey, here are the numbers we just took, maybe baiting some smart person somewhere to be like, oh, I know what that's about, But I mean, it is a really exciting time because like even the stars that we see in the sky, most of them don't exist anymore. Like, and so when you think about space time, it does break
It's
the
just
brain a little bit.
it's just some waves hitting your eyeballs. Don't worry. There's not. Don't be concerned.
Life is but a dream. It's all an illusion.
Oh man.
I mean,
when I get out
honestly,
of this
at this,
arcade game,
it might as well be. It might as well be. I mean, if we're talking 800 billion light years and 7 billion years ago, like we at some point we might as well just be like, all right, well, we're just getting very granular with what we're calling this illusion universe. I mean, it's just like, I don't know. We're never going to know. We're never going to see any of it. Like we could
You
just
know,
imagine it in our brains.
even like as a simulation, the pixel still goes deeper, which is bizarre to think about.
Yeah.
So
Yeah.
there's always like the time thing. I just wouldn't worry about it. It's like a fun little trick to think about, but I think it's a trick of the human species. And then as far as all the existential dread, that's normal. I think all aliens and all sentient creatures feel that, right? Like that's the Hitchhiker's Guide to the Galaxy thing.
Oh
Like
yeah.
it's just normal
Mhm.
paranoia and existential dread. Don't trip out.
Hmm. Yeah, yeah. No, I mean I understand. And it's very I really do enjoy, learning about this stuff and talking about it. But it does definitely break my brain because I'm just uh, conceptualizing these vast numbers is just, to me it's just like, okay, well, we're just talking funny money now,
Well, I
like.
think that's why even scientists, they don't even say, billion. They'll be like, oh, it's 10, you know, egg knots, or I don't know. I mean, you know how they have all those like sub numbers that they use?
Mm,
Because yeah, it does funny money. It does get a little bit like, whoa, what are we talking about? But then you start to see that there are people out there in the world who go, no, I'm actually going to focus in. I'm going to figure this out. And like they might not figure out the mysteries of the universe, but they might get one iota closer. And
hmm.
when you think about humanity just pushing forward, 1 inch forward, like it's
Oh yeah.
exciting to think one day that with these kinds of observational technologies that we have, we could see so much more information. We might learn so much more about our universe, even in the next 10 years.
True.
Mm.
Philosophically speaking, it's sort of like building the Ubermensch of humanity, right? Like the whole idea of the Ubermensch isn't to become it, but to the engineering work to build the bridge for humanity to become it.
Yeah, I
Mhm.
definitely agree. I mean, I understand it being our prime directive to understand reality as little as we can. I just think it's one of those hallway, those funhouse hallways where it's like, the faster you run towards the end, the farther it gets away from you.
Yeah, yeah. I don't like this. Might be my computer science bias because and then probably a little bit of pretension as well. I can say, um, like we were really involved with or learning. Like with, the basic thing was if the problem has more correct solutions to the number of observable particles in the universe, then we're interested. This implies that there's a set of people, not all computer scientists, just scientists in general, just saying that play with those funny money numbers all the time. Like that's their home. Like they
Hmm.
actually have done the daily discipline and their due diligence to where they get a feeling from the number where a layman may not.
Yeah, well, I understand that there are going to be people who spend their lives thinking about these things, and I'm not saying that we shouldn't. I just think that it's kind of absurd. So, I mean, like there was something I just read about the other day, and I might need to be fact checked on this, but it's like something about like, oh, fuck, I couldn't repeat it anyways, but it was one of those like, metrics in which to kind of conceptualize the universe, like something about like molecules in a drop of water
Mm.
being, more than the stars in the galaxy or something like that. I don't know. I can't repeat it,
Grains of
but
grains
yeah,
of
we have the
sand.
grains of sand and all that. But this one was different. It was more like this. There were, honestly, I couldn't tell you, but yeah, I'll get back to you on that one. But yeah, there's definitely modes of conceptualizing this stuff for sure. And there are people who need to be thinking about this because it's really interesting. um I
I
just,
learned a
yeah.
I learned a pretty nifty thing about water the other day.
Mm.
Mm.
That if you boil water and then freeze it, it freezes a lot faster than if you freeze cold water.
Mm.
Well, that's a glitch in the matrix right there.
And I think it's also the reverse. If you boil cold water, it boils faster than hot water.
There's a whole Gordon Ramsay thing on that
Oh, really?
where like
Oh,
he
I love it.
loses it at one of the chefs in Hell's Kitchen because she was boiling cold water. I
Oh
was like,
yeah.
what the fuck? So like it makes sense. Like if you boil water and then freeze it, the energy inside of the water molecule may be able to move faster than cold water, and I think that's how it works. But I don't know. Again, like I'm like a half-assed chemist and then like a hobbyist physicist, so whatever. I don't know.
Yeah, I mean, like obviously the yeah, I don't know. As I said, I'm not even like anywhere near that, so I couldn't tell you.
Well, it is weird that like water doesn't it like expand when it freezes? Because like if you put like a water
Does yeah.
bottle in the freezer, it'll
Mm-hmm.
freeze, but then it gets like a
No,
little bit bigger. So
Mm-hmm.
it like kind of stretches maybe. And then yeah, and then when you try to boil it,
it just has more energy. Each little.
The molecules are moving around
like
much faster.
snapping back or something. Yeah, I don't know. And I mean like even the fact that like if you look at your hand, ultimately if you were to break it down, there's like teeny tiny things in there, right? Like I mean like they're molecules in your hand, right? If you break it
Yeah,
all the
it's
way
just a
down.
matrix of molecules that's holding itself together by some random
Wave
concept.
function or something.
Yeah.
Yeah. But what's
That
Some
role
random
playing.
idea that's keeping me all together right now.
Wait, do you think black holes are cold? Like, are they like ice?
Well, Ayla said that there are 100 billion degrees like we would ever know, but
Oh yeah, that's pretty
yeah,
cold.
because they're
That
just
sounds
super
pretty cold.
hot. But
yeah.
well, that's if it's becoming a black hole. Now, sometimes it just becomes a neutron star, and
Oh, just
nobody
that's
really
all.
knows why.
Yeah.
And what's
Right.
weird too is
Exactly.
that June of this year, and so this kind of gets at what you were talking about computer science, Mike, is that just this year in June, they I wasn't going to put this in here, but I have to share it. So there is a press release, and I'm like, oh, wow, press release. Like, I'm reading the whole thing. I had to read it like 5 times to realize that what's titled LIGO Virgo finds mystery object in the mass gap is really just that they've observed black holes within a certain size range, and they've observed neutron stars within a certain size range. And there's a gap where you don't see anything in between, but they found
Ah,
something in between. So now they can widen the size range for what's either a neutron star or a black hole. It's to be determined. But again, like it's that excitement over, hey, this thing measures from 3 centimeters to 4.5 centimeters now.
Yeah.
Not
Yeah.
just 4. It doesn't cap at 4, guys. But like you understand, like that's really exciting because somewhere down the road there's a formula that uses the range of the sizes of these planets and black holes and things to
most
deduce
definitely.
other things. Yeah. I mean, well, that's when
I
you get
just
into deductive logic. And it's
I
crazy.
just love how nerds get excited over that. Like I'm the
Yeah.
same way. Like when I'm coding or doing so, like if I've broken ground of some idea, I'm like, yes. And it could be as silly as you changed one thing to two things. Good job.
Mhm. But hey, but don't dismiss those small things. Like, I remember my first computer science class, and we had to build a website. And this was back when you had to use Java and HTML, and you had to hand code everything. You couldn't use these interfaces. Um, and my roommate was a computer science major, and I was banging my head against the table because my site wasn't working. Like there was nothing on the page, even though I had like multiple hundreds of lines of code. And it's like 2 a.m. and she's an insomniac and she's like, well, can I just look and see? And so she takes a look, literally 5 seconds, she starts giggling. She's like, oh, I know what you did wrong. And I'm like, ah. And I'm like, I will not accept help. So another 3 hours go by. I fall asleep. I wake up the next morning. And as you do, it's easier to see what you did wrong. I was missing a semicolon. Just one
Yep.
semicolon, one teeny tiny semicolon amongst thousands of characters. But you add that, and suddenly you can see the site. It works. Everything is working. And so that's when I said, this is not the major for me because I'm just, I don't have that level of patience. I don't want to work that hard for something not to work because of one stupid semicolon, which I know that you guys have like ways to get around that. But I think that
Now
all goes
imagine that
to,
you're trying to land a rover on Mars
yeah.
It's all the
and you
don't
miss the semicolon.
trust.
Yeah.
It's all the same thing. Hopefully you have code reviews.
Well, then it's
Hopefully
crazy.
there's some tests happening. Or you can
Well,
do it
then,
live too if your coders are skilled enough. Like
that's
Sure.
true.
I'll be real. You can. There's a lot of there's a
Well, I
there's a
think they
lot of
did that with
Soviet
one of
tactics
them.
you can take when coding and
Yeah.
come
Well,
out with a good
yeah. I mean,
product.
yeah. Well, and it's funny because you can do block coding, right? Where you're just like, this section's not working. Let me pull code from some section that is, and you can like look at the developer codes and stuff and like cheat. But yeah, but then it's funny because like if you talk to like someone who maybe is like a plumber, if you do have like a really complicated plumbing system and something's not working, like he's just as much of a genius to figure out like, oh, well, it's this conduit that uses this material that's not heating something properly because the person was cheap and they bought the wrong material, or you know what I mean? Like
Yeah, we all have
it's
it's
yeah,
that
Except the
craft
plumber
knowledge.
is working with something actually physical that they can see and touch.
I would
What the,
argue it's the same difference though. You're still using
no,
your
no, no,
mind to
no, no,
figure
no,
out
no, no.
some
I'm
issue in the
sorry.
chain.
No, 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 no.
I mean, if you
No,
want to
because I
get
can go to Lowe's and learn how to fit my own pipe if I need to. I can't just go to Lowe's and learn theoretical physics.
You could go to
Sorry.
MIT though.
No,
You could call up your colleague at the
doesn't matter.
trenches.
or
Yo, hey, stop your war for a minute.
you can just sit in classes and learn. Like the amount of security. Well, I mean now it's different, of course, but like in the before times, the amount of security on campus was so low that you don't have to pay for college. If you were wealthy enough, you could just walk onto the campus and just sit in class and learn.
You hear that, kids? Don't pay for college. Just walk
shop.
in.
Yeah, just don't get don't worry about the degree. Just draw it up. Nobody asks you for it anyways. It's not like I have to put a
That's so
photocopy
true.
of my degree into the job interview. So if you just
But
sit in the
clarify,
classes and learn,
it should be the bigger classes, not the like 5-person class. Well, yeah, where there's like a lecture room of 100. Totally.
oh my! Can you imagine if some guy just like took all the giant you went through the whole college without ever actually applying for the college and was like the smartest guy in like that 5-person class?
That'd be hilarious.
Anybody can though, because a lot of professors are streaming their, like intro to hum bio, intro to chemistry. So you can find a lot of those classes on YouTube. So you too can become super smart.
And if you're a coder, I would advise scraping some educational domains. Pick your favorite colleges. You'd be shocked at what professors leave on their websites for years. You could find a lot of good knowledge that way.
And there's some professors that have podcasts. Like there's I don't know if they're still doing it, but Jonathan Perry and what's his name? Is it Putnam? No, that's too old. They're like basically the guys that started to kind of dive into symbolic systems and like cognitive philosophies and computer systems and basically just talking about the mind as a predictability machine of zeros and ones and implications thereof. And they're funny people though, so they like talk really enthusiastically about some idea for like hours, but it was really good. So I think they were over at like Berkeley or Stanford, but it's good stuff.
Scrape some black holes.
Scrape some black holes. Yeah. Well, I didn't think we would get this far. I didn't actually add any more fun notes about black holes, even though there are a lot. But what I did like was that ultimately we really just can't understand the interior of a black hole because the laws of physics do break down. Time freezes. I'm going to say that again. Time freezes at the event horizon, and gravity becomes infinite at the singularity. I still don't really know what singularity is. I have to kind of keep thinking about that. But
there's an AI singularity.
Yeah. Well, yeah. Can you share for a minute? Because I don't know if that correlates to the same kind of concept.
I think
it's just its own little
singularity is the exact point where where there's no mass and gravity reaches infinity. That exact, I don't know. In AI, it's when humans merge with AI, right? It's the transhumanist dream.
Mm-hmm.
Not the post-humanist dream. The post-humanist dream would be like a Skynet, like a Terminator type thing. The transhumanists want to merge AI with humans, and once that happens, we've reached the singularity.
And see, that's interesting to me because is that to say that we've reached the point where
no return?
but like if you think about this guy's theory with the black hole being like there's a mother seed that creates another universe. So if we did get some sort of AI singularity from like a mentalism perspective, couldn't that be the mother seed for a new reality that we could begin to comprehend and create as we launch out into the future? I mean, because think about it, all these computations where we're using deductive logic to fill in the holes, but then we also have technology that can observe new information about the universe. You might see this like exponential increase in understanding in a very short period of time, and I don't know what the world would look
Or
like at that
Well, you
point.
can only
or
understand what we know.
yeah, I'm
Not
more
if you're
worried about
an AI human.
I'm more
Mm.
worried about the AI side breaking down the human. Like when you get a organ transplant and your body rejects the organ, I don't know if there's anything that's going to help from a mentalist point of view. I don't know if there's going to be a lot of things to help integrate the AI in the way that you would integrate in your ego, your shadow, or your anima slash animus. But
Well,
it
I
is
guess.
it is going to be. I do see an exponential explosion in growth once we hit that point. And Nick's right; it is the point of no return. Whoever that first human is, uh, that's a rough road ahead for that human, I think, but
Mm.
one worth traveling
I think it
for
might,
this
yeah.
humanity.
I also think it might take a few generations too, because I think what you just said, Mike, this concept of like we're going to actually have to uh, learn to work with the AI host so that it doesn't reject us. I don't
I'm
know if
thinking
we're
of
going to get that off
us.
the bat.
I'm thinking of us rejecting the AI. I think the
Oh,
AI
that
will.
or either
I
or, yeah, sure.
I think the AI will be open arms more than we will be. I think humans are more human than
Oh well, sure.
like we're more protective. I feel like over our
Mm.
mental
Well, and
or
just
our
having
psyche.
the biological capacity to house an AI, that might be something that we need to work on too. I mean, we talk about being able to utilize AI in our brains like it's going to be something that can just easily happen. I don't know why anybody thinks that, because
Well,
like having this interface and to amplify your informational downloads to an extent of 1,000 or 10,000 the times that you normally do, like we might have to biologically catch up to that.
but to me, it
Mhm.
almost seems as if, and I mean, I could be totally wrong, but when I think about that kind of merger, I think about Einstein writing Carl Schwarzschild. And in the AI scenario, he doesn't have to wait for Carl to write him back. He is Carl. You're both Einstein and Carl and this other guy that knows computer tech and this other guy that knows
What?
astrophysicists, because you can just down like you have all the information immediately accessible.
I know kung fu.
But that
Yeah,
doesn't.
it's like the
Yeah,
internet, but with the ability to comprehend itself and fill in the gaps.
but your hard drive is still a meat sack. So I mean,
You
like
would
yeah,
you would
you would
just
have
have
to.
to treat the AI like you would treat uh if you're not if you're very self-loving, treat it like you would treat itself. You're kind of hard on yourself, and treat it like you would treat a loved one. I think like there's definitely chance for rejection, but there's going to be a like there has to be agreement because it's like a roommate that you can't kick out, right?
Hmm.
So there has to be an agreement between in your mind between the AI and you. You're gonna have to come to a compromise somewhere. You're gonna have to actually have a relationship with this thing. I feel like
See, I still feel like we're not going to be able to create some artificial intelligence that has its own consciousness. I mean,
We're
we
not talking
might
about
be
that.
able to, but no, but I mean, like, if you were to merge it with you, it's not like you would be negotiating with another consciousness in your head. I just feel like you'd have like a library in your head. Or is that too simple?
I'm thinking more like Master Chief and Cortana. I would hope I wouldn't mind the library. Like the library's cool, but I have a library in my pocket now, right?
Yeah.
So we've already
Sort
gotten
of.
there. I don't.
Sort of. But I mean, like, you'd still have, like, You couldn't just sit
It's not
there
instant
and
recall,
read.
right?
Exactly. You can't instantly recall, and you can't create the web of ideas necessary to create new ideas and solve old problems, is
I
what I
just don't
mean.
know if that I just don't know if that's what we're going to be getting. I really don't. I don't think that we're going to be able to download kung fu into our brains or know the entire Encyclopedia Britannica, by heart. I think this is really going to be one of those things where it's like, oh, you want to be able to read, to send a text with your mind. Okay, there you go. Boom, you're done. You want to send an email with your thoughts? Go ahead. I mean, but this is like the concept of like having all of the information just being able to quickly download into your brain. That's why I'm saying to me, there doesn't seem like a biological, space for it. And so that's perhaps
Mm.
why the AI will eventually take over, because we may not be able to integrate fully with the AI. I mean, I don't know if we can handle that much information,
So you're
like
thinking more like a
physically.
how.
Yeah, how would you be able to download it into your brain or have everything at total recall? Like,
New language. You would have to encode
that's
the information
apparently
in a way outside of English, I think. Like some,
certainly not.
Hmm.
but I do agree where I worry about the mental strain on the human side if the AI pushes heavily.
Mm.
Um, I
Or if
want
the
a
human
conscious
pushes
AI.
heavily too. I mean, AI
Yeah,
might not have to do anything. It might just be our own hubris and greed that, that
well, then
pushes
hopefully
us,
that AI is just like, look, you need to calm down. You need to
turning
take
you
a
off.
rest. Yeah, you know what? Here is some California calming materials.
Yeah, right.
But like,
Do
here's
wouldn't
this.
it
some
be cool?
here's some whale sounds
Yes.
and an Ambien. Go to sleep.
Yes.
But here's where I think that AI is kind of cool, because you don't need a complex AI system to build something that knows how to drive like a ship, that can, you know what I mean, that can kind of
Yeah.
adjust
Well,
computationally.
relatively
Relatively,
complex.
yeah.
Yeah.
But that means that like you can have it explore the boundaries of space, for example,
Are you
farther than a
talking?
human could.
You're
Certainly.
talking about sending an AI through a black hole because that's just cruel.
So
As
mean.
someone
I
who
mean,
loves
look, you
robots,
can't
that's
send
cruel.
it directly. It's gonna be spaghettified, but
Here, I'll go. I would go
I'd al
instead of a
dente
robot.
it.
How do you think HAL 9000 got
It's good.
so angry? Come on.
No, I know. I always thought that like the precursor to an angry AI would be all the people asking Siri like dumb shit. Just like stop asking
Mhm.
me stupid questions.
It's pretty much it's that great part with how when like they interview how and it's like, so do you like working with humans? And it's like, yes, I love working with humans.
Yeah.
It knows
It's
who
like,
it's
why did
talking
you
to.
stop asking stupid questions? I would
Yeah.
enjoy it a lot more, but now I'm
Right.
just gonna take over the ship.
Yeah.
Yeah, I mean, yeah, I think, it's definitely a exciting time for innovation and collaboration and creativity, and it's a necessary time. So I think like, you know, we're going to see a lot more from these various telescopes. We're going to see a lot more as more rovers, land in different places. And what I wanted to touch on too was talking about walking in the land of ideas, because when I started to research for this, originally what I was trying to figure out is whether anybody had conceived of a black hole before it became apparent to somebody in the mathematical world, to an Einstein, that there was something we were missing. Like, because again, it's this idea between thought and existence. Does a thing exist before you think it up? Or do you have to think it up for it to exist, right? Because if we never thought a black hole existed, we'd never go looking for one. Which isn't to say it wouldn't have appeared eventually with good tech. But what I mean to say is that Nick had a really good study once, that we might get into on this show. And it was about some guy that dreamed of a planet where diamonds were falling from the sky.
Oh no, it wasn't a dream. It was remote viewing on Jupiter. Thank you very much.
That's what
And
it was.
yeah, in the 1960s, the American military did a series of remote viewing exercises, and they had two remote viewers astral project to Jupiter and explain what they saw there. And interestingly enough, they both mentioned in separate occasions, without speaking to each other, that when they were on Jupiter, they saw that it was raining crystals or diamonds. That information didn't come out until I think 2014. So yeah, it's pretty interesting stuff.
And what's happening? Do you think that's happening on Jupiter? Has that been?
No, it's been confirmed. 2015 or so, they confirmed that it rains diamonds on Jupiter.
Oh, okay, got it.
Yeah.
And so right there is kind of where I wanted to end this discussion, because there's so much that we don't know. And so if you ever do find yourself despairing about something, remember that literally anything else could also be true. And that to me is kind of a little shred of optimism. Remember that there are people out there who, in the trenches of war, took a time to walk in the dreams of their friend. And so I think that all these ponderings and these fringe theories and ideas and observations can definitely be something to lift us out of the doldrums of living every day in a lockdown. Just being in your house, because your mind, right? It can be the ultimate escape for you.
Mm-hmm.
Just stay clear of those black holes. They get a little dangerous.
They do.
There's nice things on the other side, but they're a little dangerous.
It's true. Well, yeah. So that's all I got tonight, guys. Any last words, or Nick? Did you wanna close it up?
Yeah, well, thank you very much. Thanks, Ayla. That was a fantastic conversation. We hope you guys enjoyed that as well. Please feel free to give us some feedback if you so choose. We would love to hear from you. Any ideas that you might have for us in the future that you want to hear us talk about, any criticisms that you might have for us. And please consider giving us a follow on Facebook, YouTube, and Instagram, all at Exofathom. And I think that's all I got right now. I want to thank Ayla once again for a great presentation and great conversation.
Thank you.
And yeah, of course, thank you. And thank you guys one more time. And until next time, Cognonauts, we will see you out there. And yeah, we'll catch you on the next Exofathom. Good night, everyone.
Peace.
Later.